How exactly does this model achieve this? First, we will need a decent quality generator. For this, we will train a conditional GAN specialized in high fidelity images. Hello, welcome to Faction. My name is Maarten and I'm a machine learning engineer. Today we're proud to share with you our latest experiment, the anomalous dice detector. Unlike with traditional object detection, this custom model is capable of handling previously unseen damage types. So let's take a look at our setup. We have mounted an industrial-grade camera and connected it to a GPU-accelerated Jetson Nano, where GStreamer will handle the camera feed directly. We have mounted a spinning plate on top, which replicates a production environment, where a product is passing a camera for quality inspection. For our test subject, we have chosen dice as each face has a similar color and shape, yet the primary feature, the number of eyes, is always different. This allows us to harness the full power of a conditional generative adversarial network, or for short, the conditional GAN. In this series of 3 images, our first image is our captured dice. This is encoded and sent to the generator to produce a new, never before seen image, which is our second one. Once we have our real and our fake images, we can use a collection of algorithms to bring out any localization where an anomaly might be present. So, without further ado, I'll start the demo. The first 3 dice are healthy, so they will remain in the production line, but the next 3 have applied damages, so the localization algorithm will bring out any areas where an anomaly might be present, and the product will be rejected from the production line. And then the final one. Nice. How exactly does this model achieve this? First, we will need a decent quality generator. For this, we will train a conditional GAN specialized in high fidelity images. A generator network is tasked with producing new images from scratch, so from random samples, and a critic network is tasked with comparing these fake images to the target data distribution, sending back valuable information to the generator so that it can improve on its next batch of training. The fact that our generator never sees the real training data would make this an unsupervised learning algorithm, but we're also sending additional class information, which makes this semi-supervised. Essentially, we're asking the generator to produce a specific class from our dataset, and we're asking the critic if this image looks like it belongs in that particular class. Once we have a GAN capable of producing realistic images, we will need to guide the generator towards visual similarity. This is achieved by introducing an encoder in a secondary round of training. To better understand the job of this encoder, let's imagine a painter standing in a windowless room. The artist is tasked with painting a scene that it cannot see. A friend of his is present on site and can provide valuable information so that hopefully our artist can reproduce the painting as realistic as possible. This is exactly what our encoder is sending to the generator. Previously, our input was random noise, which resulted in a rich distribution from which our samples could be drawn from. The encoder can now tell the generator where on this distribution it can find the highest fidelity image, the one closest matching our target. The real magic happens when we only keep healthy images in our training dataset. The generator is therefore only capable of producing healthy-looking images. This allows us to pass damaged subjects in to compare to our healthy generated fakes. So once we have a real image and a fake image, it is really easy to bring out any anomalous regions through various algorithms. For any further details, there is a blog post for anyone interested. We believe at Faction that anomaly detection can improve your production line. So don't forget to reach out to our sales team if you want our engineers to take a look at your data to see if we could apply anomaly detection. Applied artificial intelligence is our passion.